Today we're going to look at acids and bases and how we can measure the relative strengths of these acidic and basic solutions. We can do this with something called a pH scale. pH, again, is simply a way to relate the strengths of acidic and basic solutions. pH ranges in values from 0 to 14. Anything that's a pH of 7, at least at 25 degrees Celsius, is going to give you a neutral solution. If the pH value is less than that, that's going to be getting more and more acidic, with values close to 0 being the most acidic solutions. If the pH is greater than 7, anything above 7 is going to be basic, and the most basic solutions are going to be those that are approaching 14 for a pH value. Now, to determine pH, all we need to know is the hydrogen ion concentration. The hydrogen ion concentration, if we take the negative log of that, that's going to give us pH. P in front of anything in chemistry simply means negative log of whatever comes after it. And if we have an even power of 10, the log is simply going to be the exponent. So if we had an even power of 10, for instance, of 10 to the minus 11th, the log of that would be negative 11. If we had something that was 10 to the minus 2nd, the log of that value would be negative 2. But to get pH, we're going to take the negative value for the log, the opposite of the log. So, if you will, a negative 11 or a negative 2, the opposite of that value. pH is always positive. pH is always positive. So if we look at this first example right here, where the concentration is 1 times 10 to the minus 3rd molar for the hydrogen ions, the log of that value is negative 3. But remember, we're taking the negative of that log, the opposite of that log, so pH is going to be 3. pH is never negative. If we are given a value that is not in scientific notation, you always want to change it into scientific notation. So in this case, we've got, moving the decimal, 1, 2, 3, 4, 5, 6. So 1 times 10 to the minus 6th molar in scientific notation. And with dealing with pH, I'm not going to worry about sig figs at this point. We will worry more about sig figs and pH, etc., hydrogen ion concentration at the AP level. But now, often we're just going to even refer to it as just a molarity of 10 to the minus 6th molar and not worry about the first part of the number. So, like I said, we're going to drop the discussion of sig figs right now. So, if we have a solution then that is 1 times 10 to the minus 6th molar, that would give us a pH of, yes, 6. So it's really easy to get the pH from an even power of 10 concentration for hydrogen. So we can do this backwards too. If we know that the pH is 9, to get the hydrogen ion concentration, we're simply going to change that 9 into an exponent that is negative, 1 times 10 to the minus 9th molar for the concentration of this solution. So there are another way of looking at the strength of acids and bases is by using something called POH. And POH is just like pH. Remember, all you're doing when you have P in front of anything in chemistry, it stands for the negative log of it. So if we are looking for POH, we need the negative log of the hydroxide ion concentration. And it's really important that you remember that POH we get from hydroxide ion concentration, pH we get from hydrogen ion concentration. Very important. If you get those flipped around, you're going to get some really wrong answers. The other thing that helps us to determine different characteristics about a solution is this equation. At 25 degrees Celsius, which is what we're going to assume all of our solutions are, the pH and the POH added together is going to give us a value of 14. So if we want to find pH, and we know POH, we're simply going to take 14 minus POH, and that's going to give us pH. And vice versa. If we want to find POH, we're simply going to take 14 minus pH. Those are always together going to add up to 14. So let's look at these examples. If the hydroxide ion concentration is 1 times 10 to the minus 4th molar, what is the pOH? Yes, we can get pOH directly from hydroxide ion concentration, so the pOH is simply 4. The pH, remember, is going to be 14 minus pOH, which is 4, which is going to give us 10. Double check ourselves that pOH and pH added together must give us 14, and they do. So if we know that the pH is 6, what's the H plus? Well, if pH is 6, we know that the hydrogen ion concentration is 1 times 10 to the minus 6th molar. What is the hydroxide concentration? Well, we can't get hydroxide ion concentration directly from pH. We need pOH. But pOH, remember, is really easy to find if we know pH. We simply take 14 minus 6.0, and we get that the pOH is 8. So if we know the pOH is 8, we know that the hydroxide ion concentration is 1 times 10 to the minus 8. Another cool thing, if we're dealing with even powers of 10, notice that the exponents here for our molarities of the hydrogen and hydroxide ions in this solution add up to 10 to the minus 14. So, or add up to negative 14. So that's important, another important fact that you can remember. So the next one, if pH is 5, what is OH minus? A whole lot of people would put 1 times 10 to the minus 5th molar, and they would be wrong. Because remember, we cannot get the hydroxide ion concentration from pH. We have to have pOH to get hydroxide ion concentration. So pOH is 14 minus 5, or 9. And if the pOH is 9, that tells us the hydroxide ion concentration is 1 times 10 to the minus 9th molar. Next, if the hydrogen ion concentration is 1 times 10 to the minus 2nd molar, what is pOH? We cannot get pOH directly from hydrogen ion concentration. We have to know, we can get the pH directly from hydrogen ion concentration, but not pOH. So if the hydrogen ion concentration is 1 times 10 to the minus 2nd, then the pH is 2. The pOH then is going to be 14 minus 2, which is 12. So we can use those little equations and manipulate this so that if we know only one thing about our, or one measurement about our solution, we know we can figure out the rest. Now the one thing that I would do on this that I think needs to be added in, anytime you have a concentration, you should have molarity after it. So I would add that in. Now, this is how you do the worksheet that has a table on it. This is not really on your notes, but you can look at your worksheet and see how you would fill out this table. If you know the pH is 5, then we can quickly find both the hydrogen ion concentration and pOH. Remember, pH plus pOH is 14, so if pH is 5, pOH is going to be 9. Now that we know those two values, hydrogen ion concentration we can get directly from pH. So this is 10 to the minus, and since this was 10 to the minus 6 down here, I'm going to keep that same pattern and just put 10 to the minus 5th molar for my hydrogen ion concentration. Don't have to have the 1 times in front of it. And since pOH is 9, I can find hydroxide ion concentration directly from that. So 10 to the minus 9th molar for my hydroxide ion concentration. Always use the pH value to determine whether it's acidic, basic, or neutral, or you'll get yourself messed up really fast because the pOH scale is opposite the pH scale. So always remember the pH scale. If it's less than 7, it's getting more and more acidic. If it's greater than 7, it's going to be more and more basic. So 7 is our middle ground, smaller is acidic, bigger is basic, and 7 at 25 degrees Celsius is neutral. So if the pH here is 5, then we're going to have a situation with less than 7 for a pH value. This is an acidic solution. So pause this really quick and see if you can do this bottom row yourself real quick. So hopefully, since you knew that OH minus was 10 to the minus 6th, you quickly figured that POH was 6. If POH is 6, all we need to get pH is simply subtract that from 14 and get a pH value of 8. Once we know that the pH is 8, then we know that the hydrogen ion concentration is 10 to the minus 8th molar. Since the pH is 8, which is greater than 7, we also know that this solution is basic.